Good morning. My name is Mackenzie Vedas, and for my lab experiment 10, acid and base titration 2, I will be focusing on mathematical calculations. So what we're going to look at first is some given information and what we're going to find. So the given concentration of sodium hydroxide is going to be 0.3 molar. The initial volume of the unknown hydrochloric acid solution is going to be 35 milliliters, and the volume of the sodium hydroxide is going to be 34 milliliters. So what we're going to be finding is the moles of sodium hydroxide, the moles of hydrochloric acid, the concentration of hydrochloric acid, and then the average concentration of hydrochloric acid. Now, if this is being done in the lab, we would do this in triplicate, but due to, constraints, I'm just going to do the math one time. So the first thing we're going to find is moles of sodium hydroxide. So we know that our liters of sodium hydroxide was in milliliters. So we have 34 milliliters, so this is going to be 0.034 liters because it is 10 to the negative 3 for the conversion factor. And then for moles of sodium hydroxide, that was 0.3. So when we do this in the calculator, we would get 0.0102 for our moles. Okay, so then for step 2, when we find the moles of hydrochloric acid, it's going to be a similar setup, except now we're comparing the ratio, which is 1 to 1, because when we hit that equivalency point, they are both equal. So again, we had 0.034 liters of sodium hydroxide multiplied by 0.3 moles of sodium hydroxide, and then we multiply it by this mole-to-mole ratio, which again, since we're multiplying by 1, it's just going to equal 0.0102 moles of HCl. So for our third step, as you see, we are continuously progressing through this equation. For our third step, for the concentration of hydrochloric acid, we are going to again start with 0.034 liters of sodium hydroxide multiplied by 0.3 moles of sodium hydroxide times that equivalency point, which is 1 mole to 1 mole, multiplied by 1, and then liters of hydrochloric acid. Now, if we go back to our given, we know that our initial volume of unknown hydrochloric acid solution is 35 milliliters, but again, this is in milliliters, so the conversion factor would be 0.035 liters, and that would give us molarity. So when we multiply this all out, it would be 0.2914 capital M of HCl. So now that we know our concentration of HCl, to find average, very simple, we are going to add up the 0.2914 molarity, and then again we're going to divide by 3. And the reason we were dividing by 3 was because we were doing this in triplicate. So 0.2914 plus 0.2914 plus 0.2914 is equal to, and you probably guessed it, 0.2914. And the reason we're using all the same values is because I do not have enough time to show you all the different mathematical equations that we could have done for this, had there been a variance in volumes. So now that we know all of our data, our report sheet, which I filled in ahead of time, is going to look like this. Now, normally I would have had 3 rows, but we made the note down here that it would have been done in triplicate. Thank you for watching my lab experiment number 10.